When you think about traditional green reading in golf, it's honestly a lot like trying to predict the weather by just walking outside, holding up a wet finger, and sniffing the air.
Right, just totally winging it.
Exactly. I
Yeah.
mean, you might get lucky if it's already raining, but most of the time you're just guessing based on a feeling. And, we all know the emotional reality of that on the golf course.
Oh, definitely. It can be brutal.
You're standing over a 3-foot putt to win a match. Your eyes tell you it breaks left. Your gut screams that it breaks right, and you just end up frozen over the ball. You make a tentative stroke, miss the hole entirely, and walk off feeling completely defeated.
Yeah, we've all been there. It's a terrible feeling.
But what if, instead of just sniffing the air, you had a meteorological Doppler radar system? Today, we are taking a deep dive into the mechanics of green reading. The mission here for you is to pull putting out of the realm of that intuitive, frustrating guesswork and elevate it into a predictable, science-based process.
I love that framing. It's so needed.
We're pulling directly from the core curriculum of the Puttalyze system today, specifically looking at Module 1, Lesson 5.
Yeah, and the premise we are dealing with here, it really dismantles a lot of the myths that golfers have carried around for decades. I mean, a breaking putt is not governed by how it appears to your eye. It is governed strictly by the laws of physics.
Which is a tough pill to swallow for some people.
It is, yeah. Because, well, human visual observation has gotten people around golf courses for centuries. But on the green, the human visual system is just incredibly susceptible to optical illusions.
How so? Like, what is our brain getting wrong?
Well, when you stand on a green, your brain processes massive amounts of peripheral data, right? It sees the overall shape of the green, nearby bunkers, the tree line, shadows, the horizon, and even the slope of an adjacent fairway.
Wow, so it's taking all that in at once.
Exactly. And all of that peripheral information actively distorts your perception of the ground immediately in front of you.
So the landscape is literally playing tricks on us, just feeding the brain conflicting data.
Constantly. I mean, two highly experienced golfers can stand behind the exact same golf ball, look at the exact same hole, and interpret the visual data completely differently.
Wait, really? The exact same putt?
Oh, yeah. One sees a left-to-right break, the other sees it straight. And neither is intentionally making a mistake. Their brains are just processing those optical illusions differently.
That is wild.
Right. So the most critical physical reality to understand is that the fall line, which is the direction of steepest descent, basically where gravity is pulling the strongest, is strictly local to the ball's path.
Meaning it doesn't care about the rest of the golf course.
Exactly. It doesn't matter what the overall green is doing or what the fairway 50 yards away is doing. It only matters what the surface is doing right under your golf ball.
I hear that. And, the math obviously offers a more accurate baseline. But I have to push back a little here.
Sure, go for it.
Putting is famously known as a game of feel. We hear pros talk about feel and artistry on the greens all the time. Doesn't bringing in all this rigid science kill the art of putting?
That fear of losing the art of the game is super common, but it's really based on a misunderstanding of what feel actually is.
Okay, unpack that for me.
Well, feel isn't some mystical, innate talent that you're just born with. Feel is an internal archive built on a foundation of past experience. It's trial and error over thousands and thousands of putts.
Right, reps. Just doing it over and over.
Exactly. Now think about the optical illusions we just discussed. If your visual reference points are constantly being distorted by the landscape, your past experience is based on faulty data.
Oh, I see where you're going with it.
Yeah, your archive is full of corrupted files. Therefore, your feel becomes wildly inconsistent because you're feeding it bad info.
So you're basically building a house on a crooked foundation.
Yeah.
If I missed a putt yesterday because my eyes lied to me about the slope, I'm going to subconsciously compensate for that lie on my next putt, which just compounds the error.
Precisely. Science doesn't replace feel. It provides the objective, measurable feedback that allows you to develop a much better, far more reliable feel.
That makes total sense.
Yeah, when you understand the physics of why a putt broke the way it did, you calibrate your brain correctly for the next one.
Okay, let's look at the actual variables the Puttalyze system identifies to build that objective foundation. We've got gravity, rolling friction, green speed, slope percentage, putting angle, ball speed, target speed, and time.
Right, a lot of variables.
Yeah, but the curriculum explicitly singles out time as the hidden variable in every breaking putt. Why is time so crucial?
Time is the absolute most critical factor, yet it is the one golfers ignore the most. Many players subconsciously think Gravity only kicks in near the hole when the ball slows down.
Right, because that's usually when you see it dive off to the side.
Exactly, which is why they think putts only break at the very end. But gravity acts continuously. From the very first centimeter the ball rolls off your putter face, gravity is pulling it down the slope. It never takes a break.
Wow, okay.
Therefore, the longer the golf ball remains in motion, the longer gravity has to influence its direction. More time equals more gravitational influence, which equals more break.
Wait, surely the physical distance has to matter more than time, right? I mean, if a ball travels 30 feet, it physically crosses more grass than a 5-foot putt. How can you say distance doesn't create the break? It's covering more ground.
Because distance is just a spatial measurement, gravity operates over time.
Oh, interesting.
Yeah, a longer putt stays in motion for a longer period of time. Because the ball is on the green for, say, 4 or 5 seconds instead of 1 or 2 seconds, gravity is applying that sideways pull for a much longer duration.
That makes sense.
It's the duration of the gravitational pull that forces the ball off the straight line, not the amount of grass it rolls over.
Okay, let me see if I can visualize this. So it's kind of like skipping a rock across a river. A rock thrown really fast and hard skips straight across, but a slow throw sinks quickly because gravity pulls it down.
That captures the speed element, yeah. But a better way to visualize the sideways pull on a green is driving a car on a steeply banked curve.
Okay, I'm picturing it.
If you fly around that banked curve at 90 miles an hour, momentum carries you forward. You barely feel the lateral drift. But if you take that same banked incline at 5 miles an hour, well, the longer you stay on that incline at a slow speed, the more the car naturally drifts down the bank.
Oh, wow. Yeah.
Time is the permission slip that allows gravity to do its work.
That is a great analogy. It makes a lot of sense. And this connects directly to how we evaluate the slope itself, doesn't it? Yeah. The curriculum is very firm about separating slope direction from slope percentage.
Absolutely. Slope direction answers the question, where's the ball being pulled? That is your fall line.
Okay. And slope percentage.
Slope percentage answers, how strongly is it being pulled? And this is where visual guessing completely falls apart on the golf course. Slope percentage is just the vertical change in height over a horizontal distance.
Right, rise over run.
Exactly. A 1% slope means a 1 centimeter drop over 1 meter.
1 centimeter over an entire meter. That sounds completely invisible to the naked eye. I mean, I don't think I could spot a 1 centimeter drop if I was laying flat on my stomach on the green.
You couldn't. To almost everyone, a 1% slope looks perfectly flat. But that tiny 1% difference completely changes the geometry of the putt.
How much of a difference does it really make?
A lot. If you visually guess a slope is 1%, but it's actually 2%, your chosen aim point will be far too low. Gravity is pulling twice as hard as your brain predicted, and you are going to miss below the hole.
Man, that is frustrating.
It is. This is mathematical proof that visual guessing just isn't precise enough for consistent putting.
So, if time is the ultimate factor giving gravity permission to work, then downhill putts must be absolute torture.
Oh, absolutely.
Because you barely tap the ball, meaning it's moving incredibly slowly and giving gravity maximum time to pull it offline.
You've hit the nail on the head. That is exactly why straight downhill putts terrify even professional golfers.
I thought it was just me.
Not at all. On a downhill putt, gravity is actively assisting the forward motion of the ball. Because of that, you have to hit it with a much lower initial ball speed.
Right, or it rolls off the green.
Exactly. And since the ball is moving slower across the surface, it takes much longer to reach the hole. That massive increase in time makes the ball incredibly sensitive to any minor error.
Because gravity has all day to mess with it.
Exactly. If you are slightly off on your speed or there is a tiny variance in the slope, the ball has so much time to drift that you can end up missing the cup by a mile.
And the reverse must be true for an uphill putt then. You have to fight gravity, so you smash the ball, it travels fast, reaches the hole quickly, and gravity has almost no time to pull it sideways.
Correct.
So uphill putts are mostly just a test of pure distance control, not break.
Yep, you got it.
Ah.
Which brings us to another major variable that dictates time and speed, and that is rolling friction. This is dictated by green speed. The source breaks this down using Stimp meter values.
Okay, let's define what the Stimp meter is actually doing, because we hear that term on TV all the time.
Sure. A Stimp meter is an objective measurement of rolling resistance. It's essentially just an aluminum ramp that rolls a ball at a known velocity. A higher Stimp value simply means there is less rolling friction between the ball and the grass.
Okay, and what are the standard values?
An 8-foot Stimp value is considered a slow green, 9 to 10 feet is medium, 11 to 12 feet is fast, and 13 plus is tournament speed.
Okay, wait, let me make sure I'm wrapping my head around the physics here. Let's say I have the exact same 10-foot putt on the exact same 2% slope.
Okay, keeping all that equal.
But I move from a slow, shaggy municipal green on a Tuesday to a glass-like tournament fast green on a Sunday. Because there's less friction on the fast green, I don't have to hit the ball as hard to get it to travel 10 feet, right?
Right.
Which means my initial ball speed is lower, and the ball travels with a lower average speed overall, which means it takes longer to reach the hole. So does my ball actually break more on the fast green?
Yes, absolutely. That is the light bulb moment for so many golfers.
Wow, that is completely counterintuitive.
It is, but it's true. The identical slope at the identical distance requires a completely different aim point when the green speed changes. Fast greens produce more break because reduced friction forces you to hit the ball slower.
Which increases the roll time.
Yes, which gives gravity more time to pull the ball sideways.
That completely reframes how I think about tournament conditions. We always think fast greens are harder just because the ball easily rolls past the hole, but they're actually bending the trajectory of the putt more intensely.
Yep, it's a steeper curve.
So what does this mean for how we evaluate a putt before we hit it? Because if break changes based on how hard I hit the ball, asking how much does this break seems like an unanswerable question.
It is entirely the wrong question. One of the core principles of the Puttalyze system is that break is a result, not an input.
A result, okay.
Yeah, break does not exist in a vacuum. You cannot stand behind a golf ball, look at the hole, and declare, oh, that breaks 1 cup left.
Right, because if I hammer it, it might not break at all, and if I barely tap it, it might break 3 cups left.
Exactly. The amount of break depends entirely on the energy delivered by the golfer. The only valid question is, how much will this break at my selected target speed?
Okay, so how do we standardize that?
To solve this, the system standardizes your energy delivery by having you target an entry speed of about 3 rotations per second as the ball reaches the cup.
Give me an ELI 5 here. Explain it like I'm 5. I mean, I can't be doing visual calculus in my head to count how many times the logo on my golf ball is rotating as it gets near the hole. What does 3 rotations per second actually look and feel like?
Fair question. Think of it as the ball losing its skidding energy and transitioning into a pure forward end-over-end tumble just as it reaches its final destination.
Okay, I can picture that.
3 rotations per second is essentially a ball that would travel about 12 to 18 inches past the hole if the cup were covered up.
Oh, that makes perfect sense.
Yeah, it's moving just fast enough to hold its line against tiny imperfections on the green like old pitch marks or footprints, but slow enough that if it hits the side of the cup, it will drop in rather than violently spinning out.
It maximizes the effective capture width of the hole.
Exactly. It's the Goldilocks zone for entry speed.
Standardizing that entry speed must be a game changer for diagnosing misses. Normally, if I miss a putt, I just assume I read the green wrong. I think, oh, I thought it was straight, but it broke left.
And that's where golfers get stuck. You must diagnose the process, not the result. Let's say you missed a putt low, below the hole. What actually happened?
I mean, maybe I underestimated the slope.
Well, maybe you did underestimate the slope, but it's equally possible your read was flawless and you just hit the ball too slow. Because your ball speed was low, it stayed on the slope longer, gravity took over prematurely, and the ball missed low.
Wow. And if I missed high, above the hole, I might have overestimated the slope, or I just hit it way too hard, meaning the ball zipped past before gravity had enough time to pull it down into the cup.
Precisely. And what if the ball started offline the very moment you hit it? That has nothing to do with green reading. That's a face angle or stroke mechanics issue at impact.
It's like blaming a cake recipe when you accidentally doubled the oven temperature.
That's a perfect way to put it.
The read might have been absolutely perfect, but your energy delivery was flawed. If your speed is consistent, your feedback becomes reliable. You can actually learn from a missed putt instead of just getting frustrated by it.
Let's take all of this and put you in a scenario on the course to see how it works in practice.
Put me in the scenario. I'm 15 feet away from the hole to win my Saturday match. Walk me through exactly what I'm doing before I even address the ball.
All right. The first step is to identify the local fall line right around your ball and the hole.
Okay, how do I do that without guessing?
The easiest way to visualize this is to imagine walking up to the cup and pouring a large bucket of water directly onto the grass. Which way does the water flow?
It will naturally and immediately take the path of steepest descent.
Exactly. That invisible line of flowing water is your local fall line. It establishes the absolute objective direction of gravity, completely ignoring whatever the trees or the horizon are doing in the background.
Okay, I have my water flow. What's next?
Once you estimate how steep that fall line is, the slope percentage, you determine your putting angle using the clock system.
The clock system. Okay, I'm listening.
This is a brilliant way to quantify the angle of your putt relative to gravity. Imagine a giant clock face laid flat on the green with the hole directly in the center.
Where's 12 o'clock in this visualization? Is it where I'm standing?
No, and that is the most common mistake golfers make. The clock system does not describe where you, the golfer, are standing. It is oriented strictly by gravity.
Oh, I see.
Yeah, 12 o'clock is always straight down the fall line from the hole. It is the pure straight downhill putt. 6 o'clock is the pure straight uphill putt on that same line.
Got it. So if 12 and 6 are straight up and down, then 3 o'clock and 9 o'clock would be your pure side hill putts, where gravity is pulling at exactly 90 degrees across the path of the ball.
Perfect. And every other number is a blend of those forces. A 5 o'clock putt is an uphill breaking putt. A 10 o'clock putt is a steep downhill breaking putt.
That paints such a clear picture.
Knowing your time on the clock tells you exactly how much of gravity's force is acting sideways across the ball and how much is acting forward or backward along its path.
I love how that simplifies the mental math. I don't have to guess a little left or a lot right. Once I find the 12 o'clock downhill line with my imaginary bucket of water, I just look at where my golf ball is sitting on the clock face, and the geometry solves itself.
Exactly. From there, you measure your physical distance to the hole, you factor in the green speed, the Stimp value we discussed, and you commit to your target speed of 3 rotations per second.
Right, the Goldilocks zone.
Yes. That brings us to the final calculation, which is establishing your aim point and your distance point.
Okay, aim point makes complete intuitive sense. That's a specific spot on the grass, maybe 2 feet to the right of the hole, that I am physically aiming my putter face at. But what on earth is a distance point? Am I visualizing a second hole somewhere?
Yes, effectively. You cannot separate direction and speed. Your aim point dictates the direction, but your distance point dictates the energy.
Okay, give me an example.
Let's say you have a severe uphill putt. The physical hole is 15 feet away. But because you are fighting gravity, you might need to hit the ball with the energy required for a 20-foot putt on a flat surface.
Right, because of the incline.
Exactly. So your distance point is an imaginary hole located 20 feet away. You are pacing your stroke to reach the distance point while aiming your putter face at the aim point.
Oh, that makes so much sense.
Conversely, on a slick downhill putt, your distance point might be an imaginary hole only 10 feet away.
That is incredibly helpful. It separates the where from the how hard. And once I have both of those points locked in, the final step is just absolute commitment, right? No last-second adjustments while I'm swinging the putter.
Right. Doubt is what causes those deceleration yips, where your hands twitch right before impact because your brain suddenly panics about the speed.
It's the worst feeling.
It really is. But when you have a scientific foundation, when you know exactly why you are aiming at a specific spot and exactly how hard you intend to hit it, you can make a committed, confident stroke.
Bringing all these variables together really gives you a cohesive philosophy for your next round. It's about trading the anxiety of guesswork for the confidence of objective physics.
Absolutely.
And I think one of the most vital takeaways from this entire deep dive is how we visualize the ball rolling.
Yeah, because most golfers visualize a breaking putt as a straight line that travels 10 feet and then suddenly snaps or turns right at the very end near the hole. Physics dictates that is impossible.
Because gravity doesn't take a coffee break for the first 10 feet.
Exactly. The ball follows one continuous curve from the very microsecond of impact.
It just doesn't look like it to us.
Right. The sideways movement just becomes more visually obvious at the end because the forward speed of the ball has slowed down. That increases the roll time, allowing the gravitational pull to finally dominate the trajectory. But the curve begins immediately. Understanding that continuous curve changes how you see the entire green.
It transforms the whole experience from a guessing game into an elegant, solvable puzzle. So to you listening, the next time you step onto a green, I want you to try something. I want you to try completely ignoring the horizon, the trees, and the bunkers. Look only at the local fall line right under your ball's path. Imagine pouring that bucket of water. Ask yourself, just how much has your brain been lying to you based on the surrounding scenery?
That's a great challenge. Once you stop letting the scenery lie to you, you can start letting the physics tell you the truth.
If you found today's episode valuable, please subscribe to our channel. Every subscription helps us continue producing evidence-based golf education for golfers and coaches around the world.
If you have a golf question, topic idea, or challenge you would like us to research, test, or explain, please leave a comment, contact us on LinkedIn, or send us an email.
If you're ready to improve your putting performance, join our 30-day Puttalyze Green Reading and Putting Certification course, where you'll learn green reading, speed and distance control, setup, alignment, aim, stroke mechanics, and a proven system for reading greens with greater confidence and consistency.